Hi, I'm Russell Beach, and this is a video on SAP BusinessObjects BI solution architecture and how to do it. I think the first thing to say is that although I allude to SAP BusinessObjects technology stack in this presentation, the ideas can be used across many different technologies, so they're not SAP BusinessObjects specific. The ideas are actually technology agnostic, but bear in mind that everything that we're going to talk about is around business intelligence. So I'm not talking about general solution architecture, I'm talking about solution architecture specific to BI, business intelligence. So there's kind of two parts to this. There's a solution architecture and there's a delivery model. Back in 2005, I've been working for the BusinessObjects product group for about 5 years or so, developing what we called then analytic applications, and analytics have become quite common now, but they were less common back in 2005. In 2005, BusinessObjects asked me to go to Minneapolis, to Land O'Lakes, to help the Land O'Lakes company with some issues they were having with their analytic application deployment. At the time, Chris Hadley was running the documentation for BusinessObjects and asked if he could come with me to take some notes as to how we went about resolving issues. So I agreed, and Chris came with me, and for the duration he took lots of notes. When we came back, we collaborated on a best practice white paper that we called the Rules of Engagement. And the Rules of Engagement was really how to go about establishing and deploying a large-scale analytical application solution. So we talked about things such as performance tuning SQL, but I also mixed that with ideas that I picked up from reading books on military strategy and chess. And so we talked about concepts of things such as laying down lines of communication. Now, I moved on from BusinessObjects and I worked with several organisations over the last 9 years and many BI projects. And since the time of authoring the Rules of Engagement, I've realised that when you build a house, if you can lay down a cornerstone, you can build out from it. So when I think about this, I think about a cornerstone solution. And what we're going to be talking about now is this left-hand chunk of stuff, which is your solution architecture. The stuff up here I'm not going to touch on. This is really around the delivery model for your end-to-end BI system. But I will talk about the subsystems that come out of the architecture. And what you'll find out is, as we go through the slides now, that some of my slides are slightly different to this one, and the reason for that is that the diagram became so big when I was building it out in Visio that it kept blowing out. So there's a bit more detail in the slides than you can see on this one. Okay, let's get started. Let's say that you are the BI solution architect or the BI architect. It's very, very important, and I guess it seems obvious, that you need to understand the business intelligence solution requirements. Okay, but what you should be cognizant of, and if you don't know them, you need to go and find them, the things on the left hand side: corporate strategy, a BI vision, the BI strategy, the BI mission statement, always useful to write a mission statement because it crystallizes your thinking, and the BI stakeholders. So these are the senior people that are backing the BI initiative. From those things, discussions with architects and with the business, you should be able to define the solution requirements. So this is our vision for BI, this is what we want to achieve. Okay then, the solution will need to look like this. This is our strategy for BI. In 3 years time we want to be here, and in 5 years time we want to be here. Okay, to achieve that strategy, the solution should look like blah. Once you have the business intelligence solution requirements, you can put together your business intelligence solution architecture. Now I like to think of the components within that solution architecture of the 7 pillars of wisdom, as there happen to be 7. Business architecture, information architecture, application architecture, infrastructure architecture, data architecture, integration architecture, service architecture. Of course, these are not new. Systems such as TOGAF, for instance, has some of these, such as business architecture. They'll use technology architecture. But if you are thinking about your business intelligence solution architecture, think about these 7 categories. You can create a BI solution architecture document, and the 7 categories can make up 7 different sections, big sections in that document. And what I'm going to do now is start exploding all of these 7 sections to tell you what's in them, to stimulate your thinking. Now, as I keep saying, all organisations are different. Because all organisations are different, actually what's in all of these boxes may change. You may redefine them. So this is not a prescription, it's a suggestion with ideas to stimulate thinking. Get this in place, and this will really help you to make your business intelligence successful. Business architecture. When we talk about business architecture, we're trying to understand the business. So I'm interested in business strategy, the business objectives, the business structure, the business capabilities, business process areas, process flows, and ways of working. Now you may find within your organisation that you have one or several business architects, and they already have this information. They're working on it, they're very close to the business, in which case go collaborate with them. If you don't understand the business architecture, then you have to put more work in. The way to do this is through carrying out business analysis, one-to-one interviews, and requirements workshops. But make sure that you understand the business architecture and what the business wants to achieve before you launch yourself into defining what the solution architecture will look like. Otherwise, it's possible that the solution architecture you design doesn't meet the requirements of the business strategy, doesn't meet the business objectives, is impossible to implement because you don't have the business structure in place, and requires all sorts of capabilities that don't exist within the business. Now sometimes you will be asked to create solution architecture that brings in new capabilities, but that needs to come from very senior positions, CEO, CTO, this sort of thing. Okay, so you have your business architecture in place. That's a section in the document. Let's talk about information architecture. When we talk about information architecture, and you think about how much information is in an organization these days, it's enormous. So we need to think about structural design of that information. Where does all this stuff hang out, and where does it go to? Because at the end of the day, the information is going to go into a shared information environment. Many information consumers and many business users want to consume the information from your business intelligence initiative. We need to consider in the information architecture and talk about the data flows and the lineage of that information through the business, and the meaning and use of that information. What does the information mean? Where is it explained? Do you have a clear nomenclature or taxonomy, glossary of terms? Where do business users go to get their BI information? And very importantly, we need to think about data ownership, because there may be several owners of data in the organization. There may be sensitive data. We need to think about who owns that data and go speak to them. And data contracts. When I'm talking about data contract, what I'm alluding to is that all your data will have a genesis somewhere. All the information will have a genesis somewhere. Let's say it starts in a legacy mainframe. That may be administered by a third party, and there may be a contractual agreement as to what information can be taken and how it can be extracted. There may be a contract in place, so you may need to consider those things. Don't leave things like contractual agreement and how you will access source system data to the last minute, because sometimes these things can take quite a while to get on top of. You'll almost certainly want to be doing data profiling and start that early. So here's some examples of where the data might come from a solution architecture, and in your solution architecture document you need to elaborate these things. Legacy mainframe, third-party data that you buy in, data sources such as Aspirin maybe, SAP ERP system, other data capture systems, financial applications, maybe have a call center up and running with enormous amounts of unstructured data, because although people working in a call center environment may have a set series of questions to go through, they may type up a lot of unstructured text into notes fields. Can be very valuable. E-commerce, web. So this is your click and collect, buy online, click and pay now and collect it in the store, etc. GPS satellites, so that's your location coordinate information. Point of sale, POS, can be very, very useful. And almost all products now seem to have a barcode on them. Seen frequently in supermarkets. You take a product there, scan the barcode. It's very useful for things like basket analysis. Barcode logistics. How many times now does a courier come to your home or business, and the first thing they do is swipe a barcode on the delivery box and ask you to sign for it. So you can track this stuff. Okay, loyalty card schemes can also be very useful, because web clicks through a website, they are useful, but if you could tour the web clicks to a loyalty card, that might be even more valuable. Of course, we need to be very careful around data protection and things like that. So if your solution architecture has its genesis over here, it will then need to flow and lineage through to, maybe you have a landing space, maybe you're going to build staging tables, maybe you have a requirement for an operational data store as defined by Bill Inman, maybe you have a series of third normal form tables, one truth in one place, because data is duplicated and replicated in your sources. So maybe when you want to load that, you want to load that into third normal form entity tables. Maybe you have reference data. Maybe have a slab. Now when I talk about a slab, what I'm referring to is data extracts, which may be enormous, which are used for things like data mining tools to crawl or predictive algorithms. Because for those tools to be very effective, quite often I don't want to run a data mining tool across facts and dimensions. Why not? Well, because I've already put structure and manipulation into that data, and I've put order into that data. And maybe I just want to crawl raw data so that I discover new relationships where I have made no previous definition of the structural meaning of that data, as I do when I carry out entity modeling or dimensional modeling. So a slab for me is just a big chunk of data, and it has no real structure to it apart from the structure, its natural structure when it was extracted from the system. And of course the data flow will move on from these things to things like data marts, maybe into SAP BW if you're an SAP house, maybe to SAP HANA if you want fast in-memory data. So cover off your information architecture. Keep in mind the business architecture. What information do you want for BI? And start to elaborate on all these things. Okay, lay down your information architecture, very important. This of course is before you attempt to install any business objects. You're making a reference architecture here. Okay, let's talk about application architecture. So at this point, I understand the business, I understand information, and now I want to find the best way, the best applications to deliver that information to the business to meet the business strategy and business objectives. And as I said, this is technology agnostic, but because I previously worked for business objects for several years, I've got a lot of knowledge in this area, so I'm alluding to business objects here. SAP BusinessObjects BI 4.1 Business Intelligence Platform. I'll need to install that, and it runs on something called CORBA, Common Object Request Broker Architecture. That gets installed at runtime and all the services plug into it. For this deployment, I've decided to go for a web application server. I've listed Apache Tomcat because that's supplied by Business Objects out of the box. For my ETL, I have data services. For my predictive engines, predictive analytics using KXEN. For my dashboarding now I'm using Design Studio, and I've got the Business Objects Explorer tool that I want in there, and I want a mobile capability. So I'm listing mobile survey. See what I'm doing? I'm selecting and talking about all of the applications that I want to use. There's a requirement I discovered in the business architecture from the business that we need fast data, and there's a lot of data I discovered from the information architecture, enormous amounts of data, so I'm going to be using SAP HANA. We're an SAP house in this example, so I've got SAP BW. I need to think about how all these things are going to hook into SAP HANA and SAP BW. I'm defining Irwin as my data modeling tool, and another platform that we're using will be Microsoft SQL Server 2012, and I'm also using the data mining tool from SQL Server. Okay, so I list out my applications, and I need to also start defining how all the applications hook together. Okay. You might say to me, Russell, this is really your integration architecture. Yeah, and it comes up later on, we'll talk about it. But you're going to find, when we talk about data architecture, that it can be very closely related, and is very closely related, to data architecture. So if you're thinking, does this fit in application architecture or infrastructure architecture or data architecture, you're in the right mindset. You're in a successful mindset because you're really starting to think about these things, force the discipline into your thinking, and you may elaborate things more than once or in slightly different ways. Okay, but here I want to at least allude, I don't want to select a whole series of applications that in no way can hook together. And there's a reason for that we'll come to later. It's basically that I don't want a series of BI information silos. Okay, so if I go to a single vendor, which is, for instance, SAP BusinessObjects, things become more tightly integrated. But the relationship between Microsoft SQL Server and SAP BusinessObjects BI platform is less tight. So we can use that as the RDBMS, and we can use it for the CMS and the auditing tables, but the relationship between the two vendors is not necessarily one of tight integration. So think about how all this hooks together in your application architecture. And down the bottom here I say, I've incorporated my technology architecture into the application architecture, and I build on it further with my infrastructure architecture. Remember, I'm only giving you guidelines. You might put technology architecture in here and pull out something like infrastructure architecture or application architecture. Okay, so we've got three things in place. We've forced our thinking in our discipline. We know about business architecture, we've written about that and defined that. We know about the information architecture, and we've thought about the applications that will deliver it. Now let's think about the infrastructure architecture. If you know a lot about the applications to the point of understanding the infrastructure, so for instance, for myself, I understand sizing, and I understand supported platforms for business objects, therefore it becomes easier to work with infrastructure architects. If you don't understand these things at all, you'll need to work even more closely with an infrastructure architect. They're extremely useful and valuable, so go find yourself an information architect, a good one, and start to discuss the applications and the business objectives. Now you're going to meet them and explain you need the infrastructure to deliver those applications on. Now look at the blue arrow on the right hand side. You have to have your infrastructure in place before you can install your BI application, so make sure it's the right infrastructure. Now it's quite usual, looking at the green list of components in the middle here, to have 4 environments. You may have sandboxes as well, I know that. Development environments, test environment, pre-production environment, and production environment. All of those environments need to be sized for the volumes of data that you're going to deal with, the time windows you have to load and transform data, and the applications that need to be installed, and whatever your service level agreements are to deliver timely quality data. We'll talk about that a bit more in service architecture towards the end. You may not have the boxes, so you may need to go through a procurement process, and this can take time, and that you'll need to secure budget to do that. So get on top of your infrastructure architecture early, or you may decide that you won't buy the boxes in-house now, and you may go for a cloud, or you may go for VMware data virtualization, or you may decide in some cases to store your data. Either way, you're going to need to think about licensing models for your applications and for the hardware that's going to hold them up. You're going to need to think about recovery and backup. Maybe if it's in the cloud, it's done for you. But if you're doing it yourself in-house, you need to think through that. High availability. What is acceptable system downtime, or is no system downtime acceptable? That, for instance, is going to affect whether you set up a clustered environment for your SAP Business Objects, and disaster recovery. Maybe you have another building where the whole system is replicated. One system goes down completely, the other system comes up. You want to think about security, and that's very important because you're going to be moving content ultimately from source through development, test, pre-production into the production environment. And you need to make sure that the tools that are used to do those transports, or something like Lifecycle Manager, has access and can be used across those environments. So if you've got Windows AD environments, for instance, make sure you talk with your infrastructure architect about the compatibility of the applications that you're planning to use and the security system that they have in place or are planning to put in place. Think about storage, that's very important, and here I'm talking about data volumes. How much hard disk space do we need? Do we need it on a SAN? Are we going to store it in the cloud? And communication. When I talk about communication, I'm talking about how all these different boxes and applications are going to talk together. Okay, so write up your information architecture, and if it's not existing infrastructure architecture, if it's not existing, then you probably need to price that up, because the business is going to want to know, okay, what's it going to cost me? Okay, data architecture. Now, of course, when we talk about data architecture, we're talking about data warehousing. And you see that when we discuss the information architecture, of course, we talked about data flow. So it's going to come from a source, maybe to a landing area, then out into a data mart. But here we're really getting to the nitty-gritty, the technical side of data warehousing. And you may need to undertake requirements gathering workshops at this point. I've had a lot of success with using the Agile Data Warehousing Techniques authored by Lawrence Core. Okay, so I can recommend his book, and using Beam. It's very, very useful for carrying out dimensional modeling. Business users enjoy going through that process, and you can do things fast. If there's a requirement for 3NF, third number form tables, you may undertake entity modeling, and you'll probably undertake dimensional modeling based on Ralph Kimball techniques. Entity modeling and dimensional modeling, and remember we already listed our tool, which was Irwin in this case, in our example, will give you logical models. Okay, now you should define who will own those logical models. What will the change request process be? Who's going to make changes and update those logical models? It may be that a data architect owns all of those schemas. And physical models, because a physical model may change from a logical model. Let's think about an example. In my logical model, I may have defined a composite key of 12 different key fields to make a concatenated key as a primary key. In my physical model, the DBA may want to just, for size or for the way your particular RDBMS is working, they may not want a composite key, they may just want to apply one kind of artificial key as a primary key. As long as they don't change the meaning of that table and the grain of that table, that's fine. But think about who's going to manage that. What is the relationship between the data architecture and DBAs? Think about reference data, ODS, operational data store. We alluded to that. Sometimes that's the way forwards. From your business architecture and your requirements gathering, you should understand if there is a requirement for real-time data, so pretty much instantaneous, near real-time data, or big data. How much data have you got? How are you going to manipulate, analyze and deliver it? Who are you going to deliver it to? And how fast does it need to be delivered? And at what quality? In here we also have master data management, data profiling. Be careful to specify the fact in the solution that data profiling must be carried out on these source systems. This document, the information in this document, needs to be implemented. It's no good just as a document, so timelines and resources need to be attached to it later on, and through the actual BI delivery model, data profiling needs to be done up front. You need to start to define data quality, how you're going to handle your metadata and what that is, and thinking about the data governance. Data governance starts here, not at the end. Think about your ETL system and source systems, of course. Now, as we go through these, you see that we have all these buckets, and for each thing that we've covered off so far, business, information, infrastructure, data architecture, each of these buckets you need to elaborate and explain what they mean and how you're planning to do them, how the solution will look. And each one of those can be further elaborated into subsystems. So I'm going to give you an example now. ETL system. So here's my ETL system, and in my document I start to elaborate it more. Now if you're familiar with Ralph Kimball and the Kimball Group, you'll know that this diagram here is based on Ralph Kimball's thinking around 28 ETL subsystems. So you know, where something exists and it's best practice, don't be afraid to incorporate it into your document. Of course, give credit for it. But here in the ETL system, if I just say in my solution architecture document, I need an ETL system, what does that mean? It could be interpreted in many ways and it could lose its meaning. So here I elaborate it. This elite ETL system will have 4 big components: an extraction component, transforming component, and a loading component. And the 4th one will be how we manage all those components. And then we start to elaborate, what does it mean to extract data? Okay. It means that we will carry out data profiling, and I'll define that. It means that we will make a data extraction, so we'll pull in those files and we'll define how we're going to do that. That's covered also in the information architecture. Okay, what data to extract. And by the way, in information architecture, it wouldn't be unusual for me to list 100 source files, their location and the name and where they're going to go to. Okay. Data change management. Source system data can change, and if you don't cover that off, it can feel like you're having the rug pulled out from under your feet. So you need to think about how you will handle data that changes because it's been redefined, a field's been redefined or something in the source system. Okay, now I'm not going to go through all of these, but we need to think about how we're transforming data, of course, applying surrogate keys. It may sound quite simple, but if I think about data services, I can do that quite easily within data services from BusinessObjects. With SQL Server, certainly the earlier versions, I have to do quite a bit of coding to generate or a little bit of coding to generate my surrogate keys. Okay, so you need to think about these things. How are you going to manage slowly changing dimensions? How are you going to deal with things like fact table updates, where you need to insert new values that need to go across into your production environment, and that table may have 1 billion or plus rows in it. And think about loading the table. Okay, and think about in the load, scheduling jobs. You'll have maybe a tight window. Maybe all your data needs to be loaded overnight, and maybe there's contention because maybe your mainframe legacy system, maybe it needs to do a whole load of processing, and maybe the data doesn't become available until midnight, and maybe you need data by 6 o'clock in the morning. So you've got 6 hours, but you have many source systems. So you need the infrastructure in place to be able to complete those loads. And therefore, you've done your sizing, you calculate the CPOs, and you think about things like when you design the ETL jobs, the data flows, parallel processing. And for things like historic data, whether you can do bulk loads. Think about your job scheduler. Okay, it wouldn't be unusual for me to have physical machines or VMware to have their memory and CPU probed while they're undertaking certain ETL jobs to see whether the jobs are optimized or not. And think about how you'll manage that ETL system. So what if data gets lost? How will you recover the system if something becomes corrupted, and how will you restart it? How are you going to back things up? What's the security on that? How do problems get escalated, and so on and so forth? The package lifecycle, so job or package, it's the same thing. It's going to go through a life cycle. So here you can see that I've just elaborated on the ETL system, and I would write something around this. Okay, or if I had a best practice document, I would say this best practice document exists, so we need to allude to that. Maybe I'll get someone, an ETL manager, can provide that for me, and it can be incorporated into my solution architecture. But I need to have thought through this, and not just the ETL system, but all of my elements. So, for instance, again, supported platforms, distributed architecture, Corba. I will elaborate these, and they all may break down into other systems. Now, integration architecture. You remember that I said that SAP BusinessObjects BI4 platform, and actually from the earliest release since the acquisition of Crystal Decisions, runs on Corba, Common Object Request Broker Architecture, and this facilitates the distributed architecture. So in BusinessObjects you can scale out your solution by distributing different services all running across Corba onto different machines or VMwares. We need to think about things like that. How are you going to scale your system? And if part of BusinessObjects goes down, we don't want all the lights to go off. So think about integration. Think about supported platforms. Don't make the mistake of installing SAP BusinessObjects or any other application onto a platform that's not supported by the vendor. Okay, because if you get yourself into an area where you've got defects and bug fixes and you want support, you're in a support contract, what you really want to be able to do is go back to that vendor, okay, and say, here's the workflow, you know, we click through this is the problem that occurs, and we're using the platform that you say we should be using. We have the right CPU, the right chip, the right RAM, so on and so forth. From Corba, things have developed to SOA, Service-Oriented Architecture and Web Services. So if you're hooking several different applications from vendors, if you're attempting to hook those together, it can be a bit gnarly and a bit ugly. You don't want a series of BI application stovepipes, so you need to think about how those things can hook together, maybe through service-oriented architecture and web services, and think about security. Business users don't like 100 passwords, but of course single sign-on can be a bit risky sometimes, a bit dangerous. And why do I say that? Well, because single sign-on on my mobile application, my iPad, I click, open up BI report, BI analytic, and I go straight through and I have access to data. Okay. Or what if I'm in a coffee shop and I put my iPad down and someone's watching me and they pick it up and they click, maybe they get through to sensitive data. So you want to think about at what level you're going to force passwords and security in. And of course, things such as portal integration. I'm not saying this integration architecture is exhaustive. I'm not saying any of this presentation is exhaustive, but I'm giving you ideas for structure and things that you should be considering and should be defined and documented before you launch into your BI program. You probably have a corporate portal, and you may well want to integrate your analytics into that portal. So you need to think about whether there's an integration kit and how things are going to integrate into it. I mean, SharePoint is a classic example, okay, where lots of applications are integrated into Microsoft SharePoint. Okay, integration. Service architecture. I alluded to service architecture because there will be service level agreements. Data delivery. What is your agreement for the delivery? Is it 8 o'clock to the business? Is it 7 o'clock? Is it real time? What are the requirements about data delivery? Because you're putting together a solution, you need to put together a solution that meets those requirements for data delivery and data quality. Okay, if the solution that you're thinking of and you're defining can't meet the service level agreements, you'll have to revisit application architecture and your infrastructure architecture, data architecture maybe, okay, and start to change them. So put service architecture into your solution architecture document, and it will force this discipline so that you're thinking through in a disciplined way each facet of how this solution architecture is going to be. Think about what will be the service level agreement for handling change requests, defect fixes. What about upgrades? Have you agreed with the business that you'll upgrade to a new software as soon as it's released? Maybe. How will the system be maintained? What's the acceptable downtime? And think about backups. What are the backup agreements? So under your service architecture, list all the service level agreements and make sure that your solution, your BI solution architecture, is a solution which will deliver and be able to meet those service level agreements. At the end of the day, you're writing the BI solution architecture document so that everyone involved with BI can read this architecture. It can be signed off and agreed by the senior stakeholders. The budget can be agreed, and developers, if they're not sure what they're building or what they're building to, they should have access to the solution architecture document. So for instance, they don't go and develop a set of analytics that don't meet couldn't meet service level agreements, or don't meet the business objectives. This solution architecture, once it's agreed, it should be clearly communicated to everyone. So everyone joins in the BI team as a cohesive unit, so as to successfully deliver BI solutions and BI. Okay, now this is the last slide, and in this slide you'll see on the left hand side I'm just making a point about thinking around your solution architecture. Okay, all businesses start with data silos, and data silos is simply all those different source systems. They're created by different vendors, maybe in-house, maybe third party. They don't talk together, and the real power of BI is really elaborated several years ago now by Bernard Liautaud in his book Business Intelligence, who is the founder of BusinessObjects, and he started to talk about business intelligence. And I think when he first started to define business intelligence pre-millennia, it wasn't commonly understood. Everyone says now, oh yeah, business intelligence, I understand that. But back then they didn't, and he defined how it talks about how data is in data silos, and that raw data has great value, but not in its raw state. So BI is a process of transforming that data into information, which allows business users to make powerful decisions. And of course, if you can take that data and join it up together, senior executives can look across their business, a 360-degree view. They can look at things like supply chain and marketing. What am I doing? I'm able to look at KPIs that allow me to balance things like supply and demand. It becomes very powerful. Okay, so you've got data silos. The data is extracted, and some form of data integration will occur. It'll be cleaned, transformed, joined up. May go into BIDW layers, that's business intelligence data warehouse layers. So maybe into staging tables, and then it'll be transformed into a set of dimensional models. Okay, there may be things that don't join at all to that BIDW, such as a slab that I talked about earlier for data mining. You may have SAP BW there that exists in the OLAP world, MDX, a different language, not even SQL. But there'll be some attempt to integrate the data, maybe through a dimensional bus matrix as defined by Kimball. You join everything up, and if it can't be the data, you may be trying to use applications through your integration architecture to join the data up. But what we don't want, what we want to try to avoid, are information silos. We don't want information silos. So we started with data silos. We did a whole lot of work, spent a whole lot of money integrating all this data together to get it cleaned, get it joined up, and then it comes out in standalone data marts that don't speak to each other. Now there may be some cases, there are always exceptions, but generally we don't want business intelligence silos. We want joined up data. Okay, with your business intelligence solution you have to go for gold, yeah? So you want joined up data. Well, that concludes this presentation on business intelligence solution architecture, and I hope it's been of some use to you. I hope it's stimulated your thinking, and I hope that your BI programs are going to be successful ones. Okay, I've been Russell Beach. Thanks for listening.